Hey guys, this is the second part of data, which is bivariate statistics. Now, previously, we worked with single variable statistics or univariable statistics. So there was only one variable we were measuring. So if we are trying to measure how tall everyone is, we're just measuring the height. If we're trying to find everyone's favorite color, we're just trying to find the color. Now, there's going to be two variables. So let's say, what are the sales figures for each month? So we got one variable, which is the sales figures, probably in dollars, and the other, which is time, months of the year. Or we could be asking, do tall people run faster? So there's two variables. One, we got to measure the height. Second, we got to measure speed or the time they take to run a certain distance. So guys, univariable, bivariable, it's like a unicycle has one wheel, bicycle has two wheels. Now, when we have a bivariable statistics, there is an independent variable and a dependent variable. So depending on how you ask the question, it may change. Sometimes it doesn't, but there's always an independent and a dependent. So if we were asking what are the sales figures for each month, the independent variable is the month of the year. Dependent variable is the sales figures, because the sales figures are dependent on the month of the year. Also, if we're asked whether tall people run faster, so the height is going to be the independent. The speed is going to be the dependent. Think of it as an input and output. Input is the month, sales figure is the output, the result. The height is the input, the speed is the result or the output. All right, so we are going to use scatter plots to measure or present bivariate statistics. So let's say we want to measure height and arm span. So the independent variable is your height. Dependent variable is your arm span, because we're trying to figure out whether your arm span is dependent on your height. Now the independent variable is always going to be x, and dependent is always going to be y. So let's say we make a table, we surveyed 5 people. Independent variable always goes on top. So we have the table there, and I think the scatter plot itself is pretty easy to draw. So we have got 180 and 181. On the bottom, on the axis is 180, across is 181, so you get a dot there. Same thing with these, 167, 170. 167 is somewhere here, 170 here. There we go. Just remember, when we are drawing the graph, these got to be at equal intervals. That means that each notch has to be going up by the same amount. It can go up by 1, it can go up by 2s, it can go up by 10s, but you can't change the amount that it goes up by. So number 3, what we're going to be doing is we're going to be describing the data. Now, when we're describing the data, we are talking about correlation. Correlation means whether there's a relationship between the two variables. So for example, if we're measuring one's height and arm span, do they have a relationship? Does one's height affect their arm span? We could be asking, do the months of the year have an effect on the sales figures? Or a speed of a car and the time it takes to reach a destination, is there a relationship? Now, it's important to note that correlation does not always mean causation. Correlation means that there's a relationship, and causation means something is caused by something. A common example is ice cream sales have a correlation with the sale of sunglasses. Doesn't mean that the sale of ice creams result in sales of sunglasses. It just means that, it's weather's hot. Those are the two effects of hot weather. Now, when we're describing we can describe the strength of the relationship. Strong, moderate, weak. The stronger they are, the more in line they are. So the more straight line it is, the stronger it is. Weak correlations have a wider line. So everything is more spread out. Moderate is somewhere in between. And if you have a scatter plot and it's just everywhere, then there's no correlation. Secondly, we can describe the direction of the correlation or the data. So it can be positive if it's going up, negative if it's going down, or if it's not a straight line, it's nonlinear. So a positive linear correlation is something like height and arm span. So taller people tend to have higher or larger arm spans. So as one variable goes up, the other variable goes up as well. Negative linear correlation means that as one goes up, the other goes down. So for example, speed and the time to a destination. The faster you drive to somewhere, the less time it's going to take. So one goes up while the other goes down. So it's negative. Sometimes there's nonlinear correlations. So an example would be temperature and maybe number of people out for a walk. So if it's too cold, there won't be much people going for a walk. If it's too hot, same result. Not many people out for a walk.